Hey everybody, in this video we are going to solve the polynomial inequality you see on your screen right now. We will give the solution set as interval notation, and we'll also kind of sketch it on a number line and on sort of a plane. Now this one's a little different than the last two examples for a couple of reasons. Reason number one is it's a cubic polynomial, so the factoring will look a little bit different. The graph itself, if you're doing my method with the graphing method, it's going to look a little bit different. And also because it doesn't have 0 on one side already, so we are responsible for doing that. So I'm going to subtract 3x on both sides because I need to get 0, and I would rather have a positive leading term. So x cubed plus, none of these are like terms, so I can't combine them, plus 2x squared minus 3x is greater than 0. Now, the first way I'm going to start factoring this is taking out a greatest common factor of x. That leaves me with x squared plus 2x minus 3. Now I have a quadratic trinomial. The leading term is 1. That makes things great. Some of you, I should have mentioned this in the last two videos, but some of you stink it up at factoring when the leading coefficient's not 1. So I have a factoring playlist and I explain the AC method. So search Delta Tango, AC method, whatever, and I need you to seriously imprint it on your brain, okay? Learn that. You will have mistakes forever if you don't know how to factor. Please learn how to factor. Okay, x, I'm not going over it in each of these videos. You have to get there yourself at this point, okay? I'm sorry, but it's in separate videos. I can't constantly stop to teach you how to factor, okay? 3 and 1, whenever they're 1 away, people tend to mix it up. So remember, you want a, add to that, multiply to that, m. Okay, so think like the morning, maybe you have math in the morning or something. So 3 and 1, it's multiplying. I need positive 2, so it'll be plus 3 and minus 1, and that's another x. So first x squared, outer inner, plus 3x minus 1x is plus 2x, last, minus 3. Great. Now I set each of these equal to 0 for zero product property. I'm skipping steps. I get x equals 0, I get x equals negative 3, and I get x equals positive 1. I'm going to sketch these on a number line. Not perfectly to scale, but kind of, 0 and 1. Obviously, this is not to scale, right? Good enough. So now, based on this line of the equation, say right here, I'm dealing with positive x cubed. That means my graph finishes going upward. These are my 1, 2, 3x intercepts. They all came from the factors that had first power on them. That means all of them are behaving like linear equations at that point. And like I said, it finishes pointing up. So at my x-intercept, I'm going to cut through like a straight line, but I got a smooth turnaround, cut through like a straight line. Then I got a smooth turnaround, don't make it pointy, and cut through like a straight line. And now also it's odd power. That means my ends of my graph, the left end and the right end, should be pointing in opposite direction, and they are, one side down, one side up. We are doing great. So now those are my x-intercepts. The question is asking me as for this line, this is the main line I'm analyzing, okay? When is this graph greater than 0? When is this graph greater than 0? So I'm going to grab a different color highlighter. All right, this like magenta pink. Okay, greater than 0 here. That's an arrow. Greater than 0. I don't like that it's turning into a straight line. Right there. This is where the graph's greater than 0. It's equal to 0. Let's see. Here, oh, the highlighter kind of doesn't. I think this pen I can do white. No, it doesn't let me. I guess I could use the eraser. It equals 0 on the x-axis, okay? So those points are basically going to be like excluded, right? Kind of like open circles all right there. But these intervals between negative 3 and 0, and then from 1 to the right forever, that means from 1 until infinity. That is where I'm greater than 0. So just reiterating a little bit here, what do I want to point out? The 0 is the x-axis. When are you greater than 0? When you're above the x-axis. Less than it when you're below. Equal to it when you're on it. So now the final answer, okay, with interval notation will be parenthesis negative 3 comma 0 close union parenthesis 1 comma infinity. So there's the answer, boom, 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 using interval notation. And if you really are hard pressed to do like a number line over here, -3, 0, 1, circle, 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 shade over here, arrow, shade in between, done. You want to fake like you tested your intervals, negative, positive, negative, positive. There, you faked it, but you did it in a more efficient way. Okay, so that's the end of this example. This will be on the PreCalc final exam review playlist as well as the inequality playlist. So both of those thumbnails for those playlists are on the end screen. Go where you need to go. If you found this helpful, go ahead, thumbs up. If not, if you're confused, thumbs down. Give me a comment, question, and we can work it out. That's it for now. Adios.